Good morning, children. Sugna teacher welcomes you to your new academic year 2020-21. Our topic for today's class in physics is physical quantities and measurement. We had learned last year regarding the physical quantities. So let us try to define it. Physical quantities are quantities which can be measured. We have learned some of the physical quantities, the fundamental physical quantities like length, mass, time, temperature, electric current, light intensity, volume, and many others. A physical quantity is always measured of natural non-living object. We cannot measure the physical quantity by human organs or human body parts. Physical quantities have numerical magnitude and a unit. So, if example, student length is 104 centimeter, 104 is the number, numerical magnitude, and centimeter is its unit. As Lord Kelvin said, measurement is the beginning of science. Until you can measure something, your knowledge is a meager and unsatisfactory. Let us see what does measurement mean. For a scientific measurement, we need to have a physical quantity and we need to have units. The value of physical quantity is actually the product of number and the unit. Now the precision of measurement results in the determined procedures we need to measure. So let us try to define measurement from the previous points we did right now. Measurement is a process of comparing one quantity which is measured by the quantity of same sign and is determined as unit. Measurement means or measurement implies comparison with a standard value. Now, standard value means if I say an iron block weighs 5 kilograms. So, here we are comparing the mass of the block to a standard value, that is 1 kg, and we are checking the numerical value of it. Unit. What is a unit? The standard measure of each kind of physical quantity is called a unit. We have learned last year 7 fundamental SI units of the physical quantities like mass, which is kilogram, length, which is meter, temperature, which is Kelvin, amount of substance, which is mole, time, second, electric current, ampere, and luminous intensity, candela. Out of this, let us define 4 basic physical quantities. Length, we've already done. Let's define it also. Length is distance between the 2 points. SI unit is meter and we write it as small m. Physical quantity of mass, it is the quantity of matter contained in a body. Its SI unit is kilogram and we write as kg. Time, it is the interval of occurrence of an event. Unit is second and we denote it by small letter s. Temperature is the degree of hotness or coldness of a body. It is having the SI unit of Kelvin, and since it is named after a scientist, you see the unit how we abbreviate is the capital letter K. Now let us see one experiment over here. We have a measuring cylinder. In the first cylinder, we see the marking is the initial level of water being 20 ml. In the second measuring cylinder, when we immerse a stone which is tied to a thread, here the marking we see is going to 23 ml. Now before the marking was 20 ml and after putting a stone it is turning to 23 ml. So let us see the increase in the level of water after putting a stone becomes 3 ml. This increase in the level water is due to the stone immersed, that is, the space occupied by the stone in the water. So the water level is rising. We know that matter occupies space, that is volume. Volume is the matter which occupies space. Amount of space occupied by an object is known as its volume. It is measured in cubic meters, its SI units, or even in pins and quarts. Now let us see conversion between the SI unit, the submultiple and multiple units. Let us see, volume is how much 3D space is occupied and is measured in cubes. Cube means the same number is multiplied 3 times. Now volume consists of a cube units, so we need to cube all our lengths. Now when we have to convert from kilometer cube to meter cube, we multiply 1000 raised to 3. Now when we multiply meter cube, when we have to convert from meter cube to centimeter cube, we multiply 100 raised to 3. Since 1 meter is 100 centimeter. When we have to convert from centimeter cube to millimeter cube, we multiply by 10 raised to 3 because 1 centimeter is equal to 10 millimeter. And vice versa, when we are converting from small to big, we divide, and we are converting from big to small, we always multiply. So for example, if I have to convert 3 meter cube to centimeter cube, I will write it as 3 into 100 into 100 into 100, that is 3 times 100 becomes 3 into 10 raised to 6 centimeter cube. Now there is another unit which we use for writing volume, which is liter. Now let us go for the conversions of its multiple and submultiple units. Volume of liquids and solid is usually measured as a capacity. In metric system, capacity is based on the liter or L unit. Now when we convert from a biggest unit, that is megaliter, to kiloliter, we multiply by 1000. From big unit of kiloliter to liter, again we multiply 1000, and so on. And when we go from small to big units, we divide by 1000. So for example, if I have to convert 32 megaliters to liter, I need to multiply 1000 twice, because megaliter to kiloliter is 1000 and kiloliter to liter is again 1000. So it becomes 32 into 10 raised to 6 liters. I hope you have got it. Now when I need to convert cubic meters, let us see some conversion. Now 1 cubic meter consists of 1000 decimeter. Now 1 decimeter is 1000 centimeter. 1 decimeter cube is 1000 centimeter cube, and 1 centimeter cube is 1000 millimeter cube. Now 1 meter cube is 1000 decimeter cube, and see the conversions how it happens. Now 1 decimeter cube can also be stated as 1 liter, and 1 liter is equal to 1000 milliliter. 1 liter is also equal to 1000 cubic centimeter according to our conversion. So therefore we can state that 1 centimeter cube is equal to 1 milliliter. Now for measuring volume, we need the measuring apparatus. The first one being the measuring cylinder. Now this first picture we see the measuring cylinder. These are of plastic. There are also measuring cylinder which comes in the glass. This apparatus is used mostly in lab. The second measuring cylinders, the second type which we see, is used by pharmacists. The second type of measuring instrument is measuring beaker. The first picture which we see is usually for milk or oils. The second picture which we see generally, small ones we use for household measuring cups, and the bigger ones used by pharmacists. And the third one is usually in paint and lubricants oils. Now, how to use a measuring cylinder or a beaker? So, whenever we need to use a measuring cylinder or a beaker, we generally first wash the cylinder or a beaker and make it dry. Then we fill it with a liquid whose volume needs to be measured. Now see in the picture, I know it's a little lighter, but the reading is just below 100. Now we should not be putting the liquid level below our eye level or liquid level above our eye level. The liquid level should be straight at our eye level. It should be linear. The level of the liquid should be linear with our eye level. And we have to read the meniscus at the eye level. The level of the water, the surface of the water when it's stationary, it is known as a meniscus. Now this meniscus we have to observe at a linear level with our eye. Meniscus is the upper surface of the liquid when it's curved and when the liquid is stationary. Reading the meniscus, we always read the volume from the bottom of the meniscus. Now, for finding the volume of regular objects, we have the formula. Like for volume of a cube, we have side cube, side into side into side. For volume of a rectangular prism or a cuboid, we have length into width into height, or it's also the capital B into height, which is the base area into height. Volume of a sphere has a formula 4/3 pi r cube. Volume of a circular cylinder is pi r square h. Volume of a right circular cone is 1/3 pi r square h. Whereas volume of a right square pyramid is 1/3 s square h. Now when we need to measure volume of irregular objects, we need to use measuring cylinder or measuring beakers. Now we need to immerse the irregularly shaped object into a measuring cylinder using a thread, and we should see the water level which is rising. Now let us get back to our same experiment which we did in the previous slide. The first initial level we will call as V1, which is 20 ml, and in the second one, final level what we got was 23 ml, which is V2. Now when we need to find the water displaced, the volume of water displaced, that is the increase in the water level, we will calculate by subtracting V1 from V2, that is V2 minus V1. 23 ml minus 20 ml gives us 3 ml. Now this increase in the level of water is due to the stone immersed, that is stone is occupying some space in water which is making the water level rise. So volume of our stone is equal to the volume of the water which is displaced, that is 3 centimeter cube. Now why did I write centimeter cube? Because 1 ml is equal to 1 centimeter cube. Let us summarize. We have done for the day. We have done space occupied by an object is called its volume. The SI unit of volume is cubic meter. Liquids are generally expressed in liter. 1 meter cube is 10 raised to 6 centimeter cube. 1 liter is 1000 centimeter cube. Also we know 1 liter is 1000 milliliter, and so therefore 1 centimeter cube is equal to 1 milliliter. For measuring volume, we use measuring cylinder or measuring beaker. Regular objects, volume can be found out using the formula. For irregular objects, volume can be found using a measuring cylinder or a beaker. Reading of the volume of a liquid in a measuring cylinder is done by checking the meniscus. Meniscus is the curved surface on a liquid when it is stationary. That's it for today, children. Thank you for being patient and listening. Stay safe, stay home.